Hi class, today we're looking at Chapter 7, Lesson 3, Adding Linear Expressions. What we will learn is how to add linear expressions and how to find the perimeter of a figure by adding linear expressions. A linear expression is an algebraic expression which the variable is raised to the first power. In other words, it is a number sentence with both variables, numbers, and symbols, operations, add, subtract, multiply, and divide. There are two methods in order to simplify an expression. We could, one, use models, and two, simplify the expression by combining like terms. So for our first method, using the modeling, we notice that it says 3x plus 4 plus 2x plus 1. Well, we have 3x, which represents the variable. And we use the longer rectangles, which are, in this case, I put them in blue because that means positive. Or you could simply just put a positive so you know that we're talking about positive variables. Then in the second, we have the smaller tiles. Now, these tiles represent our constants, so just the numbers themselves. And again, you could put little plus symbols to tell you that these are positive. And obviously, if it's negative, you would put a minus sign. Now, the second I have to create is the second model, so 2x plus 1. So I have two long rectangles, which are positive, they're representing the 2x, and then I'm going to put our constant as just a positive 1. So now this represents 3x plus 4, 2x plus 1, and what we can do at the end is combine everything together. So once I combine everything, I add it all up. I now have 5 of the rectangles, because 3 plus 2 is 5. So there are 5 positive. And then as for the constants, I have 5 of those constants. And the reason why it's 5, because 4 plus 1 also gets you 5. So my final answer is simply the 5 algebra tiles with the variable and then the 5 with the constant. Now to simplify, I can actually just combine like terms. So I take 3x and I add it to 2x, which equals 3 plus 2 is 5x. Then I can add 4 plus 1, and that would get me plus 5. And that would be my final answer, which is the same as the model. Now in our second problem, we're going to use negatives this time. So we're going to use modeling and simplifying. So for the first one, it says negative 4x. So I'm going to use the color red to represent the negative. And again, you could always use just the rectangle with a minus sign, and that also represents negative. So there are 4 rectangles, meaning 4 negative coefficients. Then we have 2 positive constant tiles. Then in the second expression, I have 2 negative coefficients, and then I have 2 positive constants. And so that means negative 4x plus 2, then I have negative 2x plus 2 as well. Now to simplify, I can do combining like terms, so negative 4x plus a negative 2x, same sign, keep the sign and add, so negative 6x. Then I add 2 plus 2, and I end up with positive 4. So my final answer is negative 6x plus 4, and that is the same as this result once I add it all together. So I actually have 6 of the rectangular tiles, and they are all negative. And then finally, I have 4 of the constant tiles, which are positive. And that still gives me the same result, negative 6x plus 4. Go ahead and turn your notes over to the back side now. Now, for example 1, letters A and B, you can use either the simplifying method or you can use the modeling method. It is your decision, or you can use both. That is entirely up to you. However, modeling always works best when the numbers are smaller. So when a number is larger, too large to use the tiles, then you probably should just use combining like terms. So for the first one, I'm going to combine like terms. So I'm going to take negative 2x, and I'm going to add it to the 8x. Then I'm going to add 4 plus the negative 4, because those are my constants. So now I have negative 2x plus 8x. That gives me a positive 6x, because 8 is the bigger number, but I am subtracting since 2 is negative. And then 4 plus a negative 4, that actually turns out to be 0. So then I would be putting plus 0, which means my answer is actually just 6x by itself. Then in part B, I could do the algebra tiles this time. So if I have negative 4 of the constants, and then I have negative of my coefficients, and now I have negative of my constant here. So that represents negative 4x minus 1. And then the 5x, that's positive, so I'm going to have 5 positive coefficients. And then finally, I will have 3 negative constants. And what we do differently with the negatives is that you can actually cancel things out. So if I have a negative coefficient here, it cancels out with a positive coefficient because it becomes a 0 pair. And the same thing here, negative, positive. So every time you have a negative and a positive, they cancel each other out. So now I am left over with negatives and in my constants. So I can actually just write negative 4 as my answer, because there are 1, 2, 3, 4 negative constants, and I only have 1 left over of my coefficients, and that would be 1x. So my answer is actually just 1x minus 4, or I could write it as x minus 4 as my final answer. So either one would be correct, just knowing that I was able to cancel out the coefficients. Now in this next section, we're looking at linear expressions that can be used to find the perimeter. The lengths of the sides of a golden rectangle are in the ratio of 1.162. So the length of a golden rectangle is approximately 1.62 times greater than its width. So now for part A, write and simplify a linear expression for the perimeter of a golden rectangle. So in this case, if the width is x, they're saying that 1.62 times greater of the width. So now in this case, if I want to find the perimeter, I know there are 2 sides that are going to be x, so 2 times x, plus 2 of the sides that are going to be 1.62x. And then I could simplify my perimeter formula to 2x plus then 2 times 1.62, and that gets me 3.24x. And because they both have the same variable part, I can combine them, and I add 2, so then I have 5.24x. And that is my perimeter formula. Now, in part B, find the perimeter of the golden rectangle if the width is 8.3 meters. So if the width is 8.3, then that means x equals 8.3 centimeters. So the perimeter formula I used in part A is 5.24, and I'm going to times it by 8.3. So now once I do that, all I have to do is multiply 5.24 times 8.3, and I end up with 43.492 centimeters for the perimeter. And of course, you can always round it to about 43.5, or you can just round it to 43 centimeters. Now in this last section, go ahead and complete questions 1 through 8.